Here we are on page 11 with solutions number 25 through number 30. Number 25. Here we have 9x squared minus 18x. This is a perfect square, but don't be deceived. We've got to work on that greatest common factor first. There's a 9 and an x in both of these. So we take out 9x, and we get x minus 2, which we're done. That's all we can do on that one. Number 26. 25x squared plus 14x plus 36. Ooh, I'm tempted to look at that. Perfect square, perfect square. Let's see if we get 5x plus 6 squared. 5x plus 6. And we get 25x squared. Yeah, and a 36 on the end. That's a 30 and a 30. Never make 14. What's interesting about these perfect squares is that 60x is the smallest absolute value, 60, that can possibly happen and have this thing factor. And so this guy right here is prime. He is done. He cannot go anywhere. Number 27. B squared minus 8b plus 16. You could look at this two ways. Number one, this is a trinomial with leading coefficient 1, so you could find the numbers that times to 16 and add to negative 8, and that's a negative 4 and a negative 4. Or you could look and say, hey, this is a perfect square and that's a perfect square. Let's try b minus 4 squared times itself. Make sure that works, and it does indeed. B squared minus 4b gives you negative 8b and plus 16. b minus 4 squared. Number 28. Ooh, negative x squared plus 4. I'm going to write that as a 4 minus x squared just so I can see it as a subtraction of two squares. That gives us 2 minus x and its conjugate 2 plus x. If you would have liked to, you could factor out the negative 1 and have this alternative answer, have a negative 1 and have x squared minus 4. And then you would have negative 1 x minus 2 x plus 2 with the difference of squares there. You'll notice that this is the same as that one. Both are correct, and it really doesn't matter which one you do. Number 29. 10x squared minus 22x minus 72. Can we pull anything common out? I believe we can. There's a 2 there at least. This will give us a 5x squared minus 11x minus 36. Ooh, the only way we're going to do this one, that's a perfect square, but this one's not. So we've got to take 5 times 36 is 180. Is a negative 180. Now let's jump these down and see what we can find to break up this middle term. 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36. Yeah, we better get that. 5 and 36. We can do 6 and 30. 7, I don't think. 8 can't go in because it would have to be half of 45. 9 can go in 20 times. 12 and 15. And then I think that's the size we can go. 13, 14. And as soon as we hit 15, then we start on these numbers, and we already have them. So we look to see what could get us a negative 11, and it looks like this guy right here with a negative 20 and a positive 9. So let's write that down. 5x squared plus 9x minus 20x minus 36. This came from FOIL, if you like that acronym. Take what you can out of there. That's an x. 5x plus 9 minus, what can we pull out of a 20 and a 36? Looks like a 4. Negative 4. Take out that sign for sure, so we get a 5x there plus a 9. Oh, look at that. Look at that 5x plus 9 and that 5x plus 9 right there. See, once we find these two, we break this up, and then we have 4 terms, so we're using grouping. So now we pull out this 5x plus 9 out of the whole thing, and we are left with 5x plus 9 x minus 4. Now that's the factoring of this thing. Note that there is still a 2 sitting right out there waiting for us. And that's the answer to number 29. Number 30. I'm going to write this in the best order I can. X cubed first, then the minus 2x squared plus the 5x minus the 2. Can anything come out of the whole thing? Nope, no greatest common factor. There are 4 terms. So if we try to pull something out of here, use grouping, we get x squared and x minus 2. And nothing comes out of there, so we're sunk. We are prime. This guy will not factor.